friends, very good morning. Welcome to Anu Academy. Very good morning, friends. Let us start today's class. Today's class in our channel, our subject is Theory of Machines. In Theory of Machines, today's class in our channel we are going to discuss cams and vibrations. Okay, cams and vibrations. So definitely, friends, this material will be helpful for your AE and AWE preparation. Okay, friends. So let us start today's class. Right. So material is ready now. We will start discussing this material. The size of a cam depends upon base circle. The angle between the direction of the follower motion and a normal to the pitch curve is called pressure angle. A circle drawn with center as the cam center and radius equal to the distance between the cam center and the point on the pitch curve at which the pressure angle is maximum is called pitch circle. So this is the entire explanation of a pitch circle. The cam follower generally used in automobile engines is spherical phased follower. The cam follower extensively used in aircraft engines is roller follower. So which type of follower is used for special application? Here we are having the in this material. In a radial cam, the follower moves in a direction perpendicular to the cam axis. A radial follower is one that reciprocates in the guides. Offset is provided to a cam follower mechanism to minimize the side thrust. For low and moderate speed engines, the cam follower should move with simple harmonic motion. For high speed engines, the cam follower should move with cycloidal motion. Cycloidal motion displacement diagram should be chosen for better dynamic performance of a cam follower mechanism. The linear velocity of the reciprocating roller follower when it has contact with the straight flanks of the tangent cam is given by omega into r1 plus r2 into sin theta into secant square theta, where omega is angular velocity of the camshaft, r1 is minimum radius of the cam, r2 is radius of the roller, theta is angle turned by the cam from the beginning of the displacement for contact of roller with the straight flanks. The displacement of a flat-faced follower when it has contact with the flank of a circular arm cam is given by capital R minus small r1 into 1 minus cos theta. The retardation of a flat-faced follower when it has contact at the apex of the nose of a circular arc cam is given by omega square into O cube, where OQ is distance between the center of circular flank and center of nose. Now we'll discuss vibrations. The natural frequency of free torsional vibrations of a shaft is 1 by 2 pi into root q by I, where q is torsional stiffness of the shaft, I is mass moment of inertia of the disc attached at the end of the shaft. At a nodal point in a shaft, the amplitude of torsional vibration is 0. So two shafts A and B are shown in figure. The length of an equivalent shaft B is given by. So these are the two shafts. So this is shaft A and this is shaft B. So from shaft B we have to show the length of an equivalent. So this is the equivalent shaft. So this is the difference showing in the equivalent. Okay, so these D1, D2, D3 are the different diameters of this shaft, and L1, L2, L3 are the length of the shaft. So for this what we have to show here length of an equivalent shaft B. For shaft B we have to show the equivalent length. So that is L is equal to length is equal to L1 plus L2 into D1 by D2 to the power 4 plus D3 plus L3 into D1 by D3 to the power 4. Okay, once again I will repeat it. LA length, equivalent length of the shaft B, L is equal to length is equal to L1 plus L2 into D1 by D2 to the power 4 plus L3 into D1 by D3 to the power 4. A shaft carrying two rotors as its end will have one node. A shaft carrying three rotors will have two nodes. When there is a reduction in amplitude over every cycle of vibration, then the body is said to have damped vibration. Longitudinal vibrations are said to occur when the particles of a body move parallel to its axis. When a body is subjected to transverse vibrations, the stress induced in a body will be tensile stress. The natural frequency in hertz of free longitudinal vibrations is equal to 1 by 2 pi into root s by m, where m is mass of the body in kg, s is stiffness of the body in newton per meters. The factors which affects the critical speed of a shaft is diameter of the disc, span of the shaft, and eccentricity. Next, the equation of motion for a vibrating system with viscous damping is d square x by dt square plus c by m into dx by dt plus s by m into x is equal to 0. If the roots of this equation are real, then the system will be over damped. In underdamped vibrating system, if x1 and x2 are the successive values of the amplitude on the same side of the mean portion, then the logarithmic decrement is equal to log into x1 by x2. The ratio of the maximum displacement of the forced vibration to the deflection due to the static force is known as magnification factor. In vibration isolation system, if omega by omega n is less than root 2, then for all values of the damping factor, the transmissibility will be greater than unity, where omega is equal to circular frequency of the system in rad per second, and omega n is natural circular frequency of vibration of the system in rad per second. In vibration isolation system, if omega by omega n is greater than 1, then the phase difference between the transmitted force and the disturbing force is 180 degrees. Okay, so that's all friends for today's class. I think this class will be helpful for your AE as well as AW examination conducted by APPSC as well as Telangana State Public Service Commission. Okay, so if you are having any doubts, please post in the comments box. I will give you a reply. If you have not submitted if you have not subscribed our channel, please subscribe our channel. Please like and share our channel. Thank you very much. Thank you for watching.